First, I'd like to thank you for being here, and especially the director of Valgrai and all the organization team for having invited me here, which I think is a very interesting forum so far, and a very necessary one also, given the rapid development of AI, and that it's important that we all get aware of the benefits and risks that this powerful technology brings to society. So I will speak about social robotics with a special emphasis on healthcare for people that have disabilities, mental disabilities or physical ones. So it links with the previous speaker, Isabel Ferri, that talked about a similar subject. I come from the Instituto de Robótica Informática Industrial, which is a joint center of the Spanish Council of Scientific Research, CSIC, and the Polytechnical University of Catalonia. And we are about 120 people working there, and an important task force are our robots. You can see that we have robots for outdoors, for guiding in disasters, for instance. And my specialty is in assistive robotics indoors. As you see, manipulating clothes, helping people to dress, helping to fold clothes, etc. This is my research group. It's called ROBIRI, namely Robot Perception and Manipulation Activity. And we we are a large group. At the moment, we are 68 people, as you see. And I always like to highlight in red the women in each category, because we would like to be many more, even reach parity, but it is becoming or is proving difficult. We don't reach 20%, which is very low. So I take this forum to make a call. Most of women that are here, I guess, are devoted to artificial intelligence or related fields, but it's important that more women get into technology, into developing technology, because the technology is the future, so we like our perspective to also enter technology development. Our group started in industrial robotics, in production lines, and the trend, like 15 years ago, was to move from industry to social robots. So there are robots that, for instance, move people from a wheelchair to the bed, for instance. Robots that are receptionists, that guide in large spaces like airports. And these are a bit more conflicting type of thing. Robots that are companions for children to play, robot nannies, and also robots that help teachers at school. There are some of these are real in the sense that they are operational already. And well, within our research group, we got a project. We have made this move, this shift from industrial robotics to social robotics, and thanks to this ERC project called Cloth Manipulation Learning from Demonstration, we could build this lab within the largest one, in which there are several robots at the end. We built this mock-up of a flat with two rooms, a bedroom, where you see a bed and a cupboard, etc., and then a living room, kitchen, and dining room, in which you see two robots that give some service, and that this will help me to show you some of the prototypes we have developed in this environment, thanks to other European projects we have got. Well, in this move from industrial robotics to social robotics, new challenges appear, most of them related to artificial intelligence. For instance, in industries, there are expert programmers that program fixed sequences for the robot arms. In social environments, in assistive environments in particular, the hair carers maybe do not have programming abilities or even technological ones. So it's important that robots be easy to be instructed. And moreover, it's important to personalize. No, it's not production chains, but adapting the behavior of the robot to every person that needs some care. In industrial environments, robots are usually caged with sensors, and as soon as someone enters this space, everything stops. Of course, if we like to help people rest or eat or feeding people, robots are very close to people, so we cannot stop activity. So it's important for robots to be intrinsically safe for humans. Another particularity is that in assistive environments there are lots of textiles, clothes, and well, maybe cables or all sorts of materials that are deformable. And while in industry, what has been basically solved is the manipulation of rigid objects. Because for rigid objects, just with 3 degrees of freedom of position and 3 of orientation, if you have the model of the thing, the location and orientation is fixed. While for deformables, they have an infinite dimensional state space. So it's much harder problem to plan motions in this space. The robots in industry are standalone usually. They work independently of people, separately from people. And in these environments, social environments, they are constantly interacting with people. So they need to collaborate. And finally, the type of adaptation of learning is very different. In one, it's just reaction to changes in the environment, while in assistive environments, it is very important that they adapt through learning, long life. So you see, these are the important research challenges that we are facing in social robotics and assistive robotics in particular. And I will exemplify each of them, of these challenges, how one possible solution we are developing. For instance, for easy teaching, in our lab, we teach the robot through imitation of a person. You see this girl, she wears motion capture devices in her arms and her legs, and essentially the robot mimics her movements. This requires a transfer from the kinematics of the person to the kinematics of the robot. And afterwards, the robot can improve and make the motions more smooth through, for instance, reinforcement learning. I put on the side the different papers for those of you that would like to know more about each of these works. Easy teaching is also involved in teaching forces, or what we call rigidity profiles. Because, for instance, to make beds, there are some motions in which you need to be very stiff. The robot needs to be very stiff in order to remove wrinkles, for instance. But there are other motions in which can be free. I mean, it's not necessary that the robot, even it can be disturbed and nothing happens. Oh, sorry. What happened here? well, it's not very important, but well, maybe I did something wrong. This one works. Well, we jumped to another prototype. I'm showing another challenge, which is personalization in dressing people. You see that there are several different things that can be adapted. For instance, the speed at which someone wants to be dressed, what mobility limitations they have, for instance, left arm, right arm, whether they want the robot to explain every motion or they can be quicker, and each one is taught differently. Well, our robots speak. I didn't put the voice on because it gets, I cannot speak on top and it gets a bit slow. Another type of personalization is that usually this type of robots will come from factories with a repertoire of trajectories and actions already pre-programmed. But they need to be adapted to the particularities, physical and psychical, of people. So, for instance, in a prototype of feeding robot, we applied this thing. This is how it came from, presumably from factory, and you see it's not very comfortable for the poor guy. Then it was personalized. In this case, just the caregiver could adapt the timing and the different positions of the arm, and then after retraining, it's much more comfortable for the person to eat. So this is another, this is just adapting a physical type of thing, but the same thing can be done in cognitive personalization. Coming to the next challenge, which is safety, very important in this context. We exemplify this through putting a scarf on the neck of a person without, well, I don't know the name now, but you understand, yeah. You see in the left one how the caregiver teaches how to put the scarf around the neck of the mannequin in this case. The robot can exercise. There is a camera on top and a cost function that measures how well the robot is doing, and the robot can keep exercising the skill until it is good. And then what is most interesting is the right, that you see black now, in which it puts the scarf on a person, and this person you will see that can distort the robot, and the robot keeps doing the task without making any harm to the person. They run in parallel, and this is why I'm telling you what you have to look at in each of these frames. You see that on the right, the person disturbs the trajectory, and the robot keeps doing the task. Okay. Well, he was taking the risk because he's the one developing the prototype. So another huge area of research is the perception and manipulation of deformable objects, as I mentioned before. And this entails even introducing new types of manipulation that for rigid objects do not have any meaning. For instance, when we put a tablecloth, we sometimes take on a corner, then slide through the border, and to reach the other corner, and then we do like this. This following doesn't have any sense to do in a rigid object because the corner is always at the same place. So new manipulations need to be added. And we'll see that new grippers as well. Here you will see exactly this. One robot takes one corner, and then the other robot, because this is a big tablecloth and the robot doesn't have enough large arms, so the other follows, as I said, the border up to the other corner, and then they together put on the tablecloth. A similar thing we do to put the sheets on the bed, etc. And this led us to develop a whole taxonomy of possible grasps that have sense in these deformable objects that are quite different from taxonomies that have been developed for grasps in rigid objects. We tried to be very systematic and only took into account points, point contacts, line contacts, and plane contacts, and all their combinations. And this gave us a taxonomy that we have followed. And then we looked at all the grippers that were in the market or in research labs, which of these could be implemented. And it turned out that all were very specific for particular applications. And we wanted something more general, more versatile that is needed in assistive environments. So we developed this gripper that you see here that has possibility of making a point-point contact, a line-line contact, a line-plane contact, and a plane-plane contact. It works as you see. The plane contact is implemented through opening these two fingers that open a plane, and also we needed some friction. For instance, in this application I told you of following a border, you need low friction to follow and then high friction to clamp the corner. And this is implemented through a piece that comes up and down from this upper finger in order to implement this. And well, we have applied this in several contexts. For instance, piling cloth. If you don't open the lower fingers, you don't make the plane, it doesn't work very well, as you saw. When you open them, then it does the work pretty good. So, well, we have all the demos for other particularities of the gripper. And I want to specify in particular or emphasize this work on perception and representation of the states of cloth. Because, as I said, it's an infinite dimensional configuration space because there are infinite dimensional deformations. So it's very hard to navigate in this environment. Well, it's very costly computationally, but we have an advantage. The advantage is that precision is not very important in the sense that, for instance, if you have a folded thing like this or slightly different, doesn't matter. So we only like to represent macro states, not all possible states. And we do this by these segments you see in the, we only take into account the outline and particular segments in the outline near to corners. And how do we represent? We represent the orientation of the two segments through the volume of this tetrahedron that is invariant to position and orientation as long as the orientation between the two segments is maintained. And through this, we can build a matrix of pairs of segments that give rise to the volume, different volumes of this tetrahedron, or different determinants of the tetrahedron. So this way, we get this matrix that is symmetrical, and that represents this macro state on top. And different matrices represent different of such states. So through a virtual reality, because another important thing is how do we teach manipulation sequences to fold clothes, for instance. We do it through a virtual reality setup in which the cloth is simulated while the person manipulates. So we get the advantage of knowing exactly the position and orientation and the formation of the cloth, but the versatility with which people manipulate clothes and even see the feedback and correct, which is not possible by fixed trajectories in simulation. So you see that this person, as he manipulates and folds this cloth, automatically, since we know the position and the orientation, we compute this representation of the macro state, and then we can build this type of graphs of the different states, and for further manipulations of folding in different ways, we can plan through this type of graphs. So it's a very handy way to teach how to manipulate different types of cloth. With this, I jump to the following challenge, which is collaboration with humans. I show this through this application of wearing or helping to wear shoes, that elderly people sometimes have this difficulty because they cannot reach, but otherwise they can live autonomously. So if they can have not such a complex robot, but a device to help them to wear shoes, it will be very handy. And I must say that, well, this has voice again, but the robot at all times informs first that the robot is a machine. I'm a machine, I can help you. I will take the shoe from your hand and I will put into your right foot. Are you comfortable? And keeps informing, because the person has to feel always in control of the situation. And if he gets afraid and withdraw the foot, then the robot stops and says, we can proceed more slowly or in another way, and so on. It's very important always that the person is in control and feels in control of the situation. And finally, the last challenge, as I said, was adaptation through learning. Here, we fold a t-shirt, well, not a t-shirt, a polo shirt, by driving the robots to do it, as you will see. It's a task that for humans sometimes is a bit difficult. As you see, this researcher has some trouble doing it. But he's again the one that was doing this research, so he's good at doing it. But when he does with the robot arms, of course, they oppose certain resistance, so he doesn't do such a good job. So it's important that the robot can learn from not very good demonstrations. And the way it does is that, again, there is a camera and a cost function that measures that the t-shirt is in a square or a rectangle, that it has no wrinkles, and so on. So keeps trying, through reinforcement learning, it learns to do a quite good job. With this, I jump to the following topic, which is co-creation, because these prototypes are very nice and they gave rise to many papers and PhD theses, but if they stay at our lab, it's no sense to develop them. So once we develop something that is showable, that can be shown, we go to some possible end user, some healthcare facility, and demonstrate them and see if we can engage in a co-creation of these prototypes. This gave rise to Labora. Labora is an open lab for robotic assistance. And we have several associated partners. and that come from administrations, from research institutions, from technological centers, from assistive and healthcare organizations, and also from robotics and technological companies, because we need companies. And we made this association called Labora, and we started to develop some bilateral, trilateral, etc., more sophisticated prototypes closer to commercialization. And I will show some of these. We showed, for instance, our prototype for helping people to eat, for feeding people. You will see that, well, we used our robot that has this orthopedic arm with a force sensor in the gripper, and as soon as and a camera, and as soon as the person opens the mouth and looks at the camera, the robot feeds. You see, they play all sorts of games in our lab. So this guy closed the mouth, and the robot withdrew, and then came back. And this one just closed the mouth at the moment that the robot was with the spoon inside the mouth. So the robot didn't break the teeth of the person, which was good. So it stopped for a while and then withdrew. We showed this prototype in Parc Sanitari Pere Virgili, which is a very large sociosanitary facility in Barcelona. And we showed this prototype and others, and the dressing and so on, and they said, oh, this is the killing application. We need this, because 50% of our patients need this feeding assistance. And we, the caregiving personnel, do not have enough time to feed them. And some have trouble, some have dysphagia, they cannot swallow very well, so in 10 minutes they cannot eat, and we do not have more time. So we ask families to come at lunchtime to feed them. But, well, they come very quickly, they just feed them, and they quit to work again. So it's not very pleasant for the patients. So we started together with the management in this facility, innovation, unity, the medical personnel, nursing personnel, and also the caregivers and the patients to see what else should be added. And the first thing that they said is, oh, they cannot only be fed with a spoon. We need fork, we need to be able to drink, I mean, to provide kind of, well, I know the name. Well, something to clean the mouth of the people. And so we first developed a prototype. We miniaturized, is shown here, a very small arm with a plate with with 4 dishes, say, and then there is a tool changer that changes all this type of thing. And well, this was developed through several iterations, and finally it was we conducted a pilot study with 60 patients at the facility, and you'll see here. We added also this tablet with a face, because the patients, this was a need of the patients. They said, oh, that to hear some voice from nowhere, we don't like it. We like to be able to speak to something or to, so again, the machine says, I'm a machine, I'm not understanding you, but I'm going to help you eat and so on. And we introduced this face that gives some feedback to the person. So it was pictured in our TV. Yeah, it works. So it became very popular in Barcelona, so it was featured in TV3. And several patients were interviewed, And all were very happy with this, and even one association of patients that at the beginning were very reluctant to this, they finally had an interview in which they said, oh, that was a fantastic experience. Because then one of these patients was saying, no, I'm very happy because now I'm autonomous at eating, and my son or my daughter can come later on at night or to talk to me and to give me good company, and not just feeding me and running away. So it was a very good experience. Well, I don't know how I'm doing with the time. Well, yeah, I'm doing okay, more or less. Well, another experience of co-creation was together with Fundació ACE. Fundació ACE is an Alzheimer foundation, also in Barcelona, that do diagnosis and treatment of mild dementias, such as Alzheimer. And in daycare facilities, they have like 20 patients and one therapist. And they play games through a board like this one with some tiles that have numbers or have letters, and that they can be organized in different ways. And that they pose games adapted to the limitations of each patient. So the therapist goes through the different boards, as in chess, for instance, in simultaneous games, but cannot retain very well how each patient evolves and so on. So they wanted a personalized robot. We use the robot because it's the one we have at our lab, but of course it will be miniaturized as in the previous case, because it's only necessary to have well, a face and an arm to play. And you'll see we did this pilot study also. This was during the pandemic, and the robot speaks again, but it is translated on top that you see. So the robot both provides feedback. You see through this face, it can show whether the person is doing well or not, and it can provide also help, physical help, saying, you will find the appropriate tile, for instance, here in this line. And then the person focalizes in this line and maybe succeeds. And the robot provides also encouragement. Very good, I love playing with you, and so on. So again, we thought maybe these people that are elderly people and with some disability, mental disability, would be reluctant to interact with the robot. And at first, I must say that we didn't have this face. It was the face, well, there was no face. There were two cameras looking at the person. And, well, the feedback was not so quick, in the sense that the robot had to speak. So the person, well, they weren't so eager to interact. But as soon as we placed this face with this quick feedback, just through gestures, they all wanted to play with the robot. So this interaction, fluid interaction, is very, very important in this type of settings. And I must say that the Fundació ACE are very happy because they can record, okay, I will accelerate. They can record the whole history and evolution of each patient. So a bit quick. There are many initiatives, because it's very important, an ethical deployment of this technology, as I mentioned at the beginning. And there are many initiatives, like the ones I plotted here, that can be found in the internet, so I won't say more about this. And more than in regulation, I believe in education. I think education is crucial. And well, Barbara Gross, who is a professor at Harvard, she says that by making ethical reasoning a central element in the curriculum, students can learn to think not only about what technology they can create, but also whether they should create that technology, developing critical thinking about technology. And Judy Goldsmith has been teaching one such course, I mean ethics in technology, for several years already, using science fiction. I'm very fan of science fiction, I must say. And she says that using fiction to teach ethics allows students to safely discuss and reason about difficult and emotional charged problems without the discussion being personal or becoming personal. So there are many resources in internet that one can use to teach ethics in robotics and in technology in general. One is this Teach with Movies, that they teach many different things through clips of movies. And there is this movie called Robot and Frank, that can be very useful, especially in assistive robotics, because it's a robot that assists an elderly person. There are many more. I particularly like Black Mirror. These are serious. Black Mirror, Real Humans, Better Than Us. I really recommend you to look at these series and use them with your students, because they favor debate very much. There are also novels by very famous writers like Kazuo Ishiguro. Clara and the Sun is a girl that is ill, and her mother buys her a robot to keep her company. And it's very well described, and I like it very much. And Ian McEwan wrote Machines Like Me. I like the ambiguity of the titles, machine that like me, and machines that are like me. So it's different meaning. In Spanish or Catalan, it's not possible. And well, several years ago, I also became very interested in teaching ethics to students of different technological degrees. And I wrote in Catalan a novel called La mutació sentimental, which was translated afterwards. Well, the leitmotif of the novel is the relationships that we have constructed in turn shape us. The philosopher Robert Solomon said this in relation to people. I mean, our parents, our professors, our friends, all are shaped as the world we are. With different relations, we would be different people. So now that we interact so much with technology, technology is of course shaping us. So it's very important to have this into account in developing the technology. So as I said, I wrote this in Catalan, and well, I was lucky that MIT Press became very interested in translating the novel and asked me to develop some materials to teach a course in the curriculum of computer science and engineering about this. So the novel has an appendix with 24 ethics questions, and also there are some attached online teacher guide and a 100-slide presentation that teachers can adapt as they need. And well, you have here the links where you can download both at the university level, and I also adapted to high school in Catalan and Spanish. And well, this is how the materials look like. They are organized in 6 main chapters: designing the perfect assistant, robot appearance and emotion, robots in the workplace, in education, human-robot interaction and human dignity, and social responsibility and robot morality. I must say that it looks very much robot-like, but AI has a lot to do with it. I mean, mainly it's cognitive robotics. And for instance, in this chapter, human-robot, each chapter actually is organized this way, with some highlights from the novel, then some ethical questions, some hints for a debate on these questions, and some scholarly references to further reading. And to exemplify in this chapter, human-robot interaction and human dignity. What are the questions? The questions are these. Could robot decision-making undermine human freedom and dignity? Is it acceptable for robots to behave as emotional surrogates? If so, in what cases? Could robots be used as therapists for the mentally disabled? And how adaptive, tunable robots should be? Are there limits to human enhancement by robots? This enters this cyborg type of thing, post-humans, and so on. Very quickly, we did a couple of publications related to ethics in social robotics and AI. One is surveying the literature, and the conclusion is essentially that there is a lot on human-robot interaction, dyadic interaction, but not so much on a global perspective of, for instance, how the entire healthcare system should work, how justice and not making divides because of wealth or different countries should be, etc. So there is a need to focus more on global issues. And well, I also wrote this other paper on the differences between AI and robotics, in the sense, social robotics, in the sense that there are opportunities for developing ethics in social robotics that they were not in AI because of the slower development of this technology. And I explained this. And to conclude, I was at this European Social Services Company conference last month, and I draw very encouraging future perspectives. I saw that because social services are beginning to invest in social robots. And this somehow solves or tries a solution to population aging and shortage of caregiving personnel. How elderly people could live longer at home with some technological aid. This is clear. As is clear that robots can take on routine tasks with no added human value. So, thanks to this type of robots, of technology, we can increase the autonomy of the elderly, raise the qualification of caregiving jobs, and reduce the burden for the healthcare system and for families. This is also true for AI in healthcare, as the previous speaker was showing. And with this, I conclude. Thank you very much.
Question? One question, Carmen. Do you think could be interesting or could be necessary that social robot will be empathic?
Social robots will be empathic.
With users.
Well, I only like them to be empathic in very particular cases, in the sense that it should be always clear that they are machines, that they're not cheating people, making them to think that they care about the person, and because there is this risk of isolation, that elderly people becomes comfortable with the robot, empathic, with an empathic robot, and say, oh, the robot will take care of everything. Even say to the family and to friends, oh, it's not necessary that you come. I'm very happy with the robot. That a bit happens in this movie I recommended. So I think the robot should always make clear that it's a robot. It's not taking care of or empathizing really with the person. And this is especially crucial with children, because with grown-ups that understand that they are robots and no problem. But with children, they may be confused and think, oh, this companion is very nice because always plays to the game I like and never makes any problem, makes my homework if necessary, and so I don't need any other friends. This is very dangerous. And you may think, oh, this is science fiction. It's not. I mean, many young children already have virtual game companions or playing companions. And I think this could be because, as I said, the relations that we make shape us the way we are. So if children do not get the right life experience in the windows of time of their development, they cannot catch up later on. So be careful as parents or as teachers.
Okay. Some question? Some question?
So, thank you so much for a really interesting discussion. How do you handle the ethics of the harms? So, for example, we know that when kids are constantly interacting with mobile phones, there are harms.
How do you mean that they
Yes.
get damaged?
So, at the moment, there's legislation going through in the UK to block access to social media for children. From your perspective, as you develop this stuff, how do you handle the ethics of creating something which is more compelling than a human interaction, but then may harm? Yes?
So you are asking about preventing harm.
Sí.
Yes,
Básicamente,
yes.
¿cómo controlas los peligros?
Yeah.
You know?
Well, the robots we develop are very compliant. As you see, they can be moved and they are not rigid as the ones we are used to seeing. And they have many levels of safety. It's very redundant in this sense. And besides compliance, there are active methods to test themselves to be if they are malfunctioning or that they are close to malfunction. I don't know if this is the question. I wasn't very clear.
So we have studies that show that where people share resources and must collaborate,
Yeah.
they end up being happier. If you make people independent and make them dependent on a machine, you will not improve their well-being.
No, they won't be dependent on the robots. This is another harm. No, I don't understand, sorry.
Oh, yeah.
No.
No, it just feels like we can see the harms already in our society
Mm-hmm.
of making machines more compelling and allowing people to avoid human interaction. So ethically, shouldn't that drive something about, so you're showing, for example, a machine replacing a carer, somebody feeding someone.
Mm-hmm.
But by making that person dependent on a machine, rather than forcing people to adapt, to care.
Yeah,
There's a
now I
harm.
understand what you mean.
Yeah.
Yeah, this is a risk of technology in general, and we are getting used to all sorts of appliances that take on our capacity somehow. Is the movie Wall-E, for instance, that there is a real risk of humanity losing important capacities because machines are taking them. So I think it's very important, and I say this in these ethics courses and so on, that we should retain our values as humans and our capacities, and that machines have other, because they say, oh, machines will become more intelligent than people. Well, they are in some aspects. I mean, they are very quick, they can compute very quickly, but I think what we should aim at is at the combination of their capacities with our capacities. And in this sense, there is, for instance, a very well-known experiment in which an artificial intelligence was fed with many radiography, and was able to interpret radiographies with 5% error. And humans, radiologists, made 5% error, but the errors were completely different. So when the radiologist, human, saw the diagnosis of the machine, the error reduced to 1%. This is, in my view, the way to go. Does this
Very
answer?
good. Yeah, thank you.
Thank you.
Hello, Carmen. If we have time for a last question,
I don't
last
know.
minute. Okay, because my worry was that we, in our society nowadays, we are living in a kind of loneliness problem, because you've seen, like, with social media and stuff, we get more connected with other people, but like teenagers and young people, they are more and more isolated from themselves, and we can see this in many different studies. And my biggest worry probably with this kind of technology is that it might also make us lonelier. Like, for example, I loved the experiment, or the development that you made with a robot for feeding people, which is absolutely necessary. But for example, some relatives might have the need to go to feed that person, and with doing that, they also share that moment. So it might also be a problem that when that person is autonomous, those people just don't go at all. Do you think, is there any way that we can also use robotic not only for making us more autonomous, but to help us get more in touch with other people?
Yeah, you can develop robots that, for instance, well, there are robots, if they can be called robots like Alexa, that can connect to people, say, whatever person, would you like that I connect you with your daughter? Because I know at this time your daughter is free. Or would you like that I arrange lunch with, so that you can enforce through these aids to people that they communicate more. And of course, it's a matter of also education of families. When you deploy robots, it's very important, this companion activity of educating all the involved agents. This is what I was saying, not only co-creation, also co-deployment, co-everything, that everyone becomes aware of the advantages and possible risks of this technology.
Okay, thank you very much.